-6 over 9. Good. Okay, what we're going to do is we're going to see if this answer is in lowest terms. Is there any number that can go into 6 and 9? Or we're simplified form, if this is in simplified form. And what I'm going to say is that 3 can go into both of these. So 3 can go into 6 2 times, and 3 can go into 9 3 times. So our answer is n equals -2 over 3. Okay, cool. Let's go ahead and check it. Okay, so we're going to write check. We're going to write the original equation, n plus 1/9 equals -5 over 9. For when n equals, let me scoot this over, -2/3. Okay, we're going to plug that in for n. We get -2/3 plus 1/9 equals -5 over 9. Does this equal? I don't know. We got to figure it out. Okay, so we're going to be adding, whenever you're adding fractions, you need a common denominator. We don't have a common denominator, but if we count by threes, 3, 6, 9, you can get 9. So 9 is going to be the common denominator. There's already a 9 here. We need this 3 to be a 9. So all we're going to do is multiply the bottom and the top by 3. Okay, what that gives us is -2 times 3, which is going to be -6, and 3 times 3 is 9, plus 1/9 equals -5 over 9. All right, now we have a common denominator, which is it equal? We don't know. We got to figure it out. We have a common denominator, which is 9, so we're going to go ahead and write that down there. And we have a -6 and a +1. So here the signs are different. So when the signs are different, you take the difference. So we're going to take the difference between 6 and 1, which is 5. And then we're going to ask ourselves, which number is bigger? Is 6 bigger or is 1 bigger? And I'm going to say 6 is bigger, and 6 is negative, so that means our answer is going to be negative. And we have it. -5/9 equals -5/9. So this is a true statement. Awesome, which means that n equals -2/3. That's what we stuck in here to this original equation. So that is the solution. So n equals -2/3 is the solution to the equation n plus 1/9 equals -5 over 9. All right. If you got that right, great job. Okay, on to the next one. Check it out, example 2b. We're trying to get y by itself. There is a 1/2 here. How is 1/2 related to y? Well, it's through subtraction, so we need to do the inverse operation, which would be addition. So we're going to add 1/2 to both sides. -1/2 plus 1/2 cancels each other out, and we're left with y equals 3/4 plus 1/2. Well, I'm going to go over here to the side and go ahead and figure that out. Okay, when I count by 2s, I go 2, 4. Okay, so I need to get a common denominator. I know that the common denominator is going to be 4. This is already a 4, so I'm just going to leave it as is. I need to make this 2 a 4. So I'm going to multiply it by 2 to the bottom and the top. And I get 3/4 plus 1 times 2 is 2. 2 times 2 is 4. And then I add those. I'm going to keep my little 4 in the denominator, and 3 plus 2 is 5. Sweet. There we go. So y equals 5 over 4. That's going to be my answer. It's an improper fraction, but for this one, I'm just going to go ahead and leave it as an improper fraction. Can I reduce it? No, I can't. So we're good. A lot of times when you get into algebra and higher, it is totally okay to leave answers as improper fractions. If we wanted to write it as a mixed number, we could go y is equal to 4 goes into 5 one time, and there's 1 remaining, so it would be the same as 1 1/4. But for our check, we are just going to leave it as an improper fraction. Okay, let's go ahead and do the check. So I'm going to write check. I'm going to write the original problem. And then I am evaluating it for when y equals 5/4. Cool. Let's go ahead and substitute that in for y. So we have 5/4 minus 1/2 equals 3/4. Okay, we need a common denominator. We're subtracting. And whenever you're adding or subtracting fractions, you always need a common denominator. Right now we have 2 and 4 here on the bottom, and those are not the same number. So the common denominator between 2 and 4 would be 4. So this is already a 4. Cool. We're going to leave it like that. This 2 needs to be a 4. How do we get a 4? Well, we multiply 2 by 2 and we get 4. So whatever we do to the bottom, we have to do to the top. Okay, and then we're just going to rewrite this. 1 times 2 is 2. 2 times 2 is 4. Is it equal? I don't know. We're trying to figure that out. Okay, we have our common denominator of 4, which is awesome. So I'm just going to go ahead and write that. And then we're just going to subtract the top. 5 minus 2, which is 3. And look at that. They are equal. This is a true statement, which is awesome. What does that mean? That means, oh, you couldn't see it. There you go. That means that y equals 5/4 is the solution to the original equation because that's what we stuck in for y, and that's where we got the true statement. Okay, so let's write it. Y equals 5/4 is the solution to the equation y minus 1/2 equals 3/4. And there you go. Okay, one more problem to check. How did you guys do on Check It Out example 2C? Well, let's see. Okay, so we have 3/8 x equals 6/19. Okay, we need to isolate x. We need to get x by itself. And is x by itself? No, there's this 3/8. Well, how is the 3/8 related to x? Well, it's related whenever it's like 3/8 right next to x like that. That means multiplication. So the inverse operation of multiplication would be division. However, for this particular instance, when we have a fraction, what we're going to do is we're going to multiply by the reciprocal, which would be 8/3 to both sides. Okay? 8/3. What's going to happen? These 8s are going to cancel. The 3s are going to cancel. They all become 1. 1 times 1 is 1. 1 times x is just x. So we isolated x. We got it by itself. Perfect. And then we're going to go over here and do the multiplication of the fractions. And remember, whenever you multiply fractions, first you look to cross cancel and then you multiply across. Okay, that's what we're going to do. Are there any common factors between 8 and 19? Well, it's not 2. 3 doesn't go into 8. The only other thing that goes into 8 besides 4 and 8, or just 4 and 8, and those numbers are both even, so this is odd, and you can't divide an even number evenly into an odd number. So these are relatively prime. There's no common factors between these two, so we're just going to leave it as is. Let's look at the 6 and the 3. Are there any common factors between 6 and 3? I'm going to say yes. There is 3. So how many times does 3 go into 6? 3 goes into 6 2 times. And how many times does 3 go into 3? 1 time. Sweet. Okay, now we're going to multiply across. So 2 times 8 is 16. 19 times 1 is 19. There we go. We have our answer. Is it in simplified form? I'm going to say yeah. There's no common factors there. Okay, now we're going to check it. So we're going to check. We're going to write the original equation, 3/8 x equals 6/19 for when x equals 16/19. This is going to be interesting. Let's see if it works. Okay, we're going to rewrite the 3/8 and substitute the 6/19 in for x. Okay, equals 6/19. All right, does that equal? I don't know. We're going to figure it out. Okay, the first thing we're going to do is look to cross cancel. Are there any common factors between 3 and 19? I'm going to say no. Are there any common factors between 16 and 8? Yeah, there's quite a few. What's the biggest one? I would say the biggest one is 8. How many times does 8 go into 8? 1 time. How many times does 8 go into 16? 2 times. All right, now we're just going to multiply across. 3 times 2 is 6, and 1 times 19 is 19, and look at their 6 19s equals 6 19s. That is a true statement, ladies and gentlemen. So what does that mean? That means that x equals 16 over 19 is the solution to the original equation, okay? So let's go ahead and write that. X equals 16 over 19 is the solution to the equation 3/8x equals 6 over 19. If you got all 3 of those right, yokodenki mashita, you did a good job. Okay, we'll see you next time. Peace out. Bye.